All right. So, we're in 9.4 today. We're starting on page 27. All right. So on page 27, we've got a little let's match what kind of correlation coefficient that is with its description. 4 of them to match. Give you a minute to get it done. Go. First one, A, an R value of negative 0.44. We got scripts. Weak negative. Do you agree with weak negative? I'd go moderate negative because it's closer to negative 0.5, right? Yeah, I'd go a moderate negative there. B? Strong positive? Yeah, I'd go strong positive there. C? C? Weak positive? And D, negative 0.95. Strong negative. Okay. Okay, I go along with that. All right, let's dive into it. Okay. So Aaliyah loves to cook and collect recipes. Okay. She started her own food blog to share her love of food and passion for cooking. She hopes to build up a following and to eventually get sponsors so that her blog can become a source of income. The web service that hosts her site provides some analytics that she likes to look at and make decisions about future posts. Last week, she collected this data. And so she's got all this data now, and she's gone through it. The first set of data shows the number of visits to the site each day, starting with Monday. The second set of data shows how many recipes of each type were downloaded that week. Okay? So, maybe it was in the bottom down there. There it is. Yep. Okay. Yep. So this is number of visits. Okay. And this is downloads, right? Is that what they said? There's how many downloads. Okay. So this would be Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday, right? Because they said it was by the day. Yeah. Right, let's talk. Pencils down. We're not going to write anything today. We're going to talk. Question of the day is, what do you see? Tell me what you see between these two. Compare the two displays of data. What similarities and differences do you observe? Okay? So what do you see? What do we know? What can we find out? What can we infer? What don't we know? All that good stuff. Floor is open for discussion. Lily, sorry first. Okay, so we don't know that. Do we all agree? And we just know that there's some breakfast, lunch, dinner, snacks, and desserts coming. Okay? Right? What do you say? I'm looking at no, looking through Billy to get to you. Yeah. Mm-hmm. Okay. Do you know what the difference is between those two? Yep. Okay. Do you remember? Anybody remember which one is which? Histogram?
Yeah.
Okay, which one's the histogram?
This side.
Left side?
Yeah.
Okay, yep. And what's the right side then?
Bar graph.
Bar graph, yep. Left side's just the bar graph. Yep. Yep. Yeah, sometimes you gotta do that. Then you gotta do left makes the L. Yep. What else do we see? Does that matter to us though? No. It's just a scaling. Okay. Quick
The
question.
right one isn't going up by like days. It's going up by like types.
Okay. Okay. Like types of the downloads of the recipes that they
Yeah.
downloaded? Yeah. Okay. What else do we see? If this were your website, how would you use this data? What's the first thing that would pop out to you? Anna?
I would post our dinner or dessert recipes.
Because why?
Because people see those.
Okay. All right. Those are your most popular ones to download. Yes. Ed? Okay. Why do you think that is? Because it's what? Because it's weekend. People have more time to cook on Friday and Saturday. Yeah. Yeah. Okay. Willie, did you have your hand up? What times they're downloading it? How? I'm with you. I'm with you. So we're missing a lot of information on these, right? So that what you're basically getting at? Yeah. Yeah. Okay. One thing that jumps out to me is the fact that there's a lot of people going to this website, but there's not a lot of people actually downloading from this website. You understand what I'm saying? Okay. So like there's 15 people that visited on Monday, 6 on Tuesday, so that's 21. I'm gonna guess 8 on Wednesday, so that's 29. 9 on Thursday, so that's 37. Going with 17, so that's 44, 54, and 21 is 72. So 72 people visited the site, but they only had 5, 8, 16, 27, 32 downloads. Okay? Right? That's basically all we can get out of these, right? Okay? All right? Let's see the next set of data. Our next set found that her most popular recipe was for her special chewy, moist brownies. She checked the analytics and found that during the week, 30 people had checked out the brownie page. The next two diagrams both represent the data for the number of minutes that people spent on the brownie page. So this was getting what you were talking about, Lily, right? Like minutes that they spend on the site. Okay? Okay? So we need to compare these two pieces of data then. Okay, get them on that same moment again. Try it. Okay. So let's talk here now about, so these are data for the number of minutes that people spent on the brownie page. So one is a histogram, right? What's the other one? A dot plot, okay? So now let's compare these two. So I would guess on here, I would guess that this would be it would be minutes on the horizontal, number of minutes spent on the site versus then like, the total that they had on there. Yeah? What do you got? Okay. For both? What about the top one? That's what I was trying to get. Is that same day? Anna?
On the bottom one, you can see like the exact number of minutes, but the top, it's like
Okay, just dumps them in, right? Yeah. Okay. Good, Will. Kind of like how they added the 0 on the front end too. I think that's more for so that they can, need your dots stacked up right at the end of your. Good observation. Which one's more helpful? What?
Because it gives you more information. If the top one is just ranges, the bottom one you can see like the individual people who stayed on for how long. Also find out like
Yeah, I would concur. The bottom one is much more informational. Okay? So do you think that there's, what is it, 5, 10, 15, the 17 people in the 15 to 18 minute range were like me, and they pull up the website, they have the website open while they're making the recipe, and then make it, and then click off of it? Yeah. But sometimes, and I don't know how these analytics work, but like one thing that also pops out to me is because of the way that I cook. Sometimes I do, have the website open, and I go do a step, and then I come back, and my phone or my iPad has gone to sleep, but shut off. I don't know what kids call it these days. Gone black. Okay? So would that still be, am I still logged into that site even though it's, doesn't log, you know what I mean? Like so some of these ones and twos could be deceiving because they might be combined with a 6 and a 9, and then they're making, they're kind of making. Okay? Okay? All stuff, this today is literally just about thinking about the data and the different ways that we can represent it, and what it all means, and all that fun stuff. Okay? All right? So that's why there's this in this discussion there is no wrong answer. Okay? There's one more representation that she could see, the box plot, sometimes called the box and whisker plot. Which one's the box plot? One on the right. Okay? Okay? I am assuming that this is also for that same set of data that we were just doing with minutes on, because this graph is the same as the one that was above it. Okay? So I'm going to assume that this is, again, minutes versus number, minutes on the site. What do you got, Anna? Talk to me.
the median is 15. The quartile 1 is 6. Quartile 3 is 16.
So what does that mean?
The IQR is 10.
Okay. 10? Yeah, it's 10. because I was going off of the median. Yes, 10. It is 10. You were correct. Hard to get me to correct it. Okay. What else?
I can't remember the word, but it's like stronger.
Left skewed because the median pushed to the right. Okay. This would we agree that this data is left skewed? Because the median is pushed off to the right, which makes sense. If we scroll back up, I gotta scroll back up. You just have to look up halfway up the page. If we scroll back up here, I mean our data. We got a lot of data over here on the right side. Okay, which means we're skewed left. Okay, because remember it's that opposite thinking that mathematics likes to do all the time. Okay, I like it. All right. For some reason, she likes those histograms and wants to use them more. Okay? So she should look for center. Measures of center are the mean and the median. Shape. Okay? But there's different, so then there's these different skewed, or these different shapes of data. Okay? Okay? So skewed right would be means all your data is on the left. Okay? Skewed left means the majority of your data is on the right. Symmetric, have you guys heard of the bell-shaped curve before? Okay? And in statistics, we call it a bell-shaped curve because it looks like a bell. Okay? Okay? So that's called a bell-shaped curve. So that's what a symmetric set of data would look like, a bell-shaped curve. Okay? Bimodal means it's pretty evenly spread out, but it's not a bell-shaped curve. It's kind of like a two-humped camel. Okay? All right? And then a normal or uniform means it's all the same. Okay? Now, my question to you is, how do we know where like the mean and the median are on a bar graph? Or excuse me, on a histogram? How do we know where those are? But remember, I would say yes if it was a dot plot. But remember, we're just dumping, like there's ranges here in these. They're not necessarily 1, 2, 3, 4, 5. You know what I mean? So how do we know? What? You can. It's hard to find it exact, but you can kind of get a close guess. Okay. So, for instance, what I'm saying is, in the symmetric one, the mean and the median, the average and the middle, are going to be probably somewhere right here in the middle. Right? Because the data is evenly spread out, so it's going to be somewhere close to the middle. Okay? On a bimodal, again, depending on where those are, I would say it's somewhere in the middle. Okay? Over here on a skewed left one, that middle is probably going to be somewhere over in here. It's going to be skewed the same as the data. Okay, so it's going to be pulled over a little bit. On a skewed right, it's going to be there. And when it's uniform, it's going to be smack dab right there in the middle. spread tells us how wide or how spread out. I mean, that's literally why we call it spread, because it tells you how spread out your data is. Okay? All right? So, what I want you to do now is we'll skip number 4, but let's go. So we're not using technology here now. There we go. There we go. So now you got to pick up a pencil. So 4B, I want you to make me, and this is literally you're just making one up. Okay, so you're making me a box plot with a median of 5 and a range of 15. Okay, draw me a picture of a box plot with a median of 5 and labeled and a range of 15. Yes? Okay, so then this number, this blue number here, for me, would have to be somewhere between 1 and 5, right? Okay, I'm going to say 4. This blue number here has got to be somewhere between 5 and 16, right? I'm going to say 10. Does that work? Does that fit the criteria? Does yours have to be exactly like mine? Nope. The only thing that yours has to have is it's got to have this, right? And the difference between these two numbers has to be 15. Everything else can be different, right? Can we have negative numbers? As long as your median is still positive 5 and your range is still 15, right? Yep. Right? So it's not asking for to be exact. It's literally just asking for you to have the median be positive 5 and the range be 15. Okay? All right. Let's take a peek now at your homework for this evening. What does mean mean? Average. Okay. What does median mean? Middle. Okay. So we got to line them up in order. Gotta find the middle one. Okay. All right. Like that one. Aiden's test scores for that. Mean, mean. Yep. Mean and median. We're skipping that. Yeah. Yeah. So we're going with this one. Yep. Yep. Did I forget to tell you that yesterday? Sorry, we're on page 34. Okay. So you're crossing out the 9-4 homework. Okay. Okay. Sorry, I thought I had told you this already. I'm sorry. My fault. Crossing out the 9-4 homework. Now the 9-5 homework in your packet becomes the 9-4 homework. Okay? Alright? So cross out lesson 5, put in lesson 4. Okay? It's already fixed on your sheets. Okay? On your stamp sheets, it's already good. Okay? Or it should be, the numbers should be good on this one. Yep. Yep. Okay? Alright? Mean and median, we're good there. Mean and median, we're good there. Both grades calculated. That's a thinking problem. We can handle that one. Alright? Love it. Okay. Ooh, that one looked like we just did that one today. That's a good one. We can handle that one. Bunch of different correlation coefficients there. Love it. Oh, more correlation coefficients. Multiple choice. Yes, please. Ooh, that's good. I like that. I think that's it, right? We're going up to 37, right? That's the last page. Yeah. Oh, no, there's more. Goes to 40. Caramba. Okay, ooh. Making a histogram. Or no, frequency. Yep. Which would be best to use, yep. And then make that representation that you choose. Love it. Wink, wink, nudge, nudge. What should those be? Both of those should be what? Actually, I lied. The first one should have been a bar graph, right? There's no data to go along with it. It's just colors. Second one should be a histogram. Yeah, yeah. Box plots. Heck yeah. Looking at a box plot, which one's easiest to, oh yeah, yeah, yeah. Love it. Good stuff. This is good homework. I love it. Do it. Go for it.